All right, picking up where we left off, if you recall, I said that we cannot use lenses to focus things down in the gamma ray, X-ray range. So one of the technique we can use is shine a light source through something that has a repeating pattern. That repeating pattern causes particular diffraction patterns to come out. We essentially can back calculate what something must have looked like in order for it to produce that pattern. This again comes in with the technology of a camera that can take a picture around a corner, right? It's utilizing the same technology. This is one technique, and this works fairly well for looking at things such as proteins. But if we just want to see something smaller than a microbe, but maybe bigger than this, we do have another possibility, and that's utilizing an X-ray beam. Now, an X-ray beam actually falls down about in the same frequency as the larger gamma rays, so it kind of falls down in here. So it's a good size for molecular visibility, but here, instead of seeing how it diffracts through something, we can essentially see how it um, either reflects off of a surface or does not pass through a surface. So here's two different versions. One is a scanning electron microscope. Here we take a surface, and in order to see this, what we have to do is essentially spray whatever surface it is with a very molecular coating of metals, typically like gold or something. Um, this usually involves destroying whatever sample is there, so this is a very destructive process. But then we can shine light onto a surface and see it reflect off, and then we can generate an image based upon that. So this is scanning electron microscopy. This is good for seeing things on a surface. We also have something called transmission electron microscopy, which is where we use little bits of metal in stains that we can adhere to particular molecules within the cell. And so here, dark is where the electrons are not passing through, and lighter is where they do pass through. So we can kind of see it that way. With both of these, the color here is essentially completely artificial. We do not see any color at all. This produces a black and white image that we can then colorize to make it easier to understand what we're looking at. So, concept 6.1, biologists use microscopes and tools of biochemistry to study cells. Here's the range of all the different things we can look at. So, up the human height, down in this egg or cell and bacterial range, we cannot see these. We have to use a microscope. Anything smaller than that, we have to use various electron or X-ray beam visualization techniques. All right, starting off most simply, we have light microscope, light passing through, very difficult to see, we don't have much contrast. If we add stains, we can add contrast, but it also kills the cells. Here we can utilize something called phase contrast to amplify any minor difference, essentially, and make the background light look less bright. We can also use fluorescence. Here we cannot see the light illuminating the object, so it appears on a black background. But what we can do is see the light that is absorbed by fluorescent dyes, and then that excites electrons, it releases light at a wavelength that we can see. This typically produces an image that is very messy. So if we pass that light through a small hole, such as we do in confocal, we can essentially sharpen things up. We can also sharpen this mathematically, and we can have new techniques that kind of uses a combination of both of those. Things that are even smaller that we can't see, such as the surface of a cell, we need to go down to the X-ray range in order to visualize things. Um, or I'm sorry, down to the X-ray range. And this will allow us to see much, much smaller things. This is all essentially coming down to the wavelength of light, depends on what we can and cannot see.